Let's look at the second example that's a little bit more complicated. I strongly recommend that we do not leave negative leading coefficients inside the factors. So this 3x plus 12 won't really bother us, because if you remember, if you multiply a graph by 3, that's just going to change things that we already didn't know. So multiplication by 3 will not really affect the graph in the sense that our graph is no longer scaled. We don't know the y-coordinates of important points and so on. This one is really important to deal with algebraically because y equals 1 minus x is the same as minus x plus 1, and that behaves a little bit differently, right? It changes sign at x equals 1, but it changes from positive to negative, and that would be a little bit more complicated. So you do not have to factor out that, but if you leave negative leading coefficients, then in the table, first you have the positive signs, then the 0, then the negative signs. My recommendation is to factor it out, and then you don't have to worry about those directions. Minus x plus 1 is the same as minus x minus 1, right? This is minus x, this is plus 1. And then x minus 2 is already as reduced as we need it. And then this 2 will not bother us much, but it is still good to factor out the leading coefficients because then we can easily read the zeros. Okay. So now what do we have? We're going to gather all the numbers up front. We have a 3, a negative 1, and a 2. So we have a multiplier of negative 6. And then 4 linear factors, x plus 4 times x minus 1 times x minus 2 times x minus 5. So we're going to graph this. Now actually, instead of 4 factors, we're going to have 5. This is going to be our last factor. You can start with that, but you will see that I have some visual reasons to leave that as last. So the 4 zeros are at negative 4, plus 1, plus 2, and plus 5. These are the x-intercepts of this function, and these are the only x-intercepts of this function. These 4 points split the real number line into 5 intervals. First negative infinity to negative 4, then between negative 4 and 1. First negative infinity to negative 4, then from negative 4 to 1, then from 1 to 2, then from 2 to 5, and finally 5 to infinity. Okay, so let's see the factors. So the first factor is x plus 4. Now what happens to x plus 4? X plus 4 takes a 0 at negative 4, and it's negative before, positive after. The next factor is x minus 1. X minus 1 has a similar behavior, but now the 0 is at 1, and it's negative before, positive after. X minus 2 has the same behavior, but the change in sign around the 0 takes place at x equals 2, negative before, positive after. And then x minus 5 will have this change at x equals 5. So I left negative 6 before because then you have this nice, this one will never change sign. So then you have this nice triangular pattern. You can include it as the first line, especially if you tend to forget it. Then put it in as soon as you can. Okay, so now we're going to harvest the fruit of our labor column by column. The first column has 5 negative numbers multiplying each other. That's negative. The second column has 4 negatives and a positive. After a while, you're going to realize that it doesn't matter how many positive numbers are there. It's just the negative ones we need to worry about. So 4 negative numbers multiply to a positive. Here we have 3 negative numbers, 2 negative numbers, and just 1 negative number. That 1 negative number is negative 6. After a while, if x is large enough, all these linear factors with their positive slopes are going to be positive. Okay, this is what our graph is going to reflect. So here we have the x-intercepts. So here is our little table. Based on that, before negative 4, the graph is negative, so it comes into the picture like this. Then, from one side of negative 4 to the other side, we change sign from negative to positive, so that means we just go through like this. And then we turn around and we head towards 1. At 1, there is a change in sign from positive to negative, so we're going to dive under the x-axis. Notice I didn't even bother with the y-axis. We don't know the scales anyway. Now, at x equals 2, there is a change in sign from negative to positive, and at x equals 5, we're going to change sign for the last time from positive to negative. So this is the graph. We have no idea which one is taller. The top of these humps may not be at the center, at the midpoint of these 2 points. As a matter of fact, it isn't there. So there's not that much that we know. We just know the end behavior is large. We know it's smooth and continuous. And where is this thing positive and where is it negative? So that's the graph. Thank you for watching.